Okay, so 1-4, you guys, is about inverse functions. You may recall them from last year, but anything we did last year, you might already notice is kind of stepped up a notch. So for inverse functions, we're going to remind you what an inverse is. We're going to talk about the graphs of inverses. We're going to even talk about how you can deal with trig functions for inverses. And we did those right near the end of the year last year. So again, all of this should kind of be reviewed, but it's going to be bumped up a notch. You're sitting in calculus. You know how that goes. Okay. So remember some things about inverses. They have to pass the vertical and horizontal line test. The vertical line test just tells you that it is a function. The horizontal line tells you that is a one-to-one function, so that every x is paired with exactly one y, and every y is paired with exactly one x. That's the only way for us to do that inverse relationship and flip them back and forth, okay? So if you're looking at the graph, just check, does it pass both of those things? Now, sometimes we'll make adjustments to the function. Let me give you an example. So if we have our good old parabola, we do quadratics in so many different things. You'll notice that it passes the vertical line test perfectly. Does it pass the horizontal line test? It does not. And so because of that, sometimes what you'll do is you will physically chop the parabola in half. And if we only consider just one half, now it doesn't have to be the positive half, sometimes it's the negative half, I don't know, it depends. But if we only consider just that half, now it passes the vertical line test, it passes the horizontal line test. So it's called a restriction on the domain. So if we just restrict the domain a little bit, sometimes it'll become what we want it to become. So please note that that might have to happen depending on the functions we're working with. So remember, last year we found some inverses. So what are you going to do? So you're going to write the f of x as a y. You're going to switch the x and the y, and then you're going to find the new y, okay? For the domain and range, the domain of f is going to become the range, because what did we do? We turned the x's and y's. The range of f is going to become the range of f inverse is going to become the domain of f inverse. So they're going to be switching them things around because the x became the y and the y became an x. Example, if the point 1, 2 is a point in our function, then the inverse is going to have the point 2, 1 in it. Inverse notation just puts that little -1 next to if the function is f or g or whatever the heck it happens to be. So that does not denote any sort of power. That is just a mathematical way for us to denote an inverse. But it's important to know that the domain of one becomes the range of other. That's why a square becomes a square root. Square roots we can always only put positives in, right? So that's why if you restrict that domain, they're going to go back and forth perfectly. Everybody have that down. Okay. So if we look at these functions, it says determine whether they're one-to-one. Okay. Now this, I kind of avoided a little bit last year. This is called, there's one that's called a step function. And then there's a stair and a ceiling. So one, it looks like it's above you, and one, it's your steps. This is the step function, and it's on the integers. So it's like 0.2 stays at 0, 0.3 stays at 0, 0.4 stays at 0. And then as soon as we get to 1, everything from 1.1 and 1.2 and 1.3 and 1.4 stays at a height of 1. And then as soon as we get to 2, it jumps up, and all the 2s, 2.1, 2.2, 2.3, and everything in between stays at 2. And that's a step function. Now, they've asked us to determine if it's one-to-one. So a one-to-one function passes a vertical and a horizontal line test. This passes a vertical line test. Vertical line test. It is a function. It is one of the parent functions I avoided last year. But does it pass the horizontal line test? It sure doesn't. Any little piece there, that horizontal piece has an infinite number of little 1.2, 1.7, 1.895, you know, all those numbers in between. Okay, so this one's a no. Okay, so it's not one-to-one. So we couldn't find an inverse of that. It's impossible to find an inverse of that. Okay. Now, you might recall this one down here was one of our parent functions. We didn't avoid this one. This one down here was our reciprocal function, 1 over x. Let's look at it. So it's a function. It was a function, our parent function. We didn't call it a function just by mistake. It is a function. So this one here already passes the vertical line test. Now let's check horizontal line test. This is an odd function. Odd functions, if we turn them 180 degrees, don't they become exactly what they started with? So it should make sense that they should pass it, but let's just draw some horizontal lines. And you know, I'm sorry. My drawing skills are so good. Even this part here, even this little section here, it does, a vertical line does just hit it once. That is not vertical. Even though it looks like it has a vertical tail, it is just kind of, you know, going down a little bit, down a little bit. So it does have a little slope down to it. And so it does, that tail is never flat. It's just going down and closer to the x-axis. So this one is, yes, it's a one-to-one function. I should probably write it like that. It's one-to-one, meaning if we wanted to find the inverse, we could. The inverse of this, it's its own inverse. It doesn't happen very often, but it's its own inverse, okay? Does that make sense so far? Any questions about what we got so far about those functions and how to look to see if it's an inverse? Make sense? Kind of, a little bit? Okay. Okay, so we're going to draw a picture. We're going to find its domain and range, and then we are going to say, hey, it's an inverse. No, it's not. Or what is its inverse? Okay, so we've got this function, f of x equals 3x minus 4. Write it in y notation, not f of x. So we're going to write it as y equals 3x minus 4. Now, remember what we have to do to find the inverse. We're going to switch them. We're going to switch them. So x equals 3y minus 4. And you're going to solve for that y. So we are going to be focusing on solving for that y location right there, okay? So it's just a simple switch around, you know, add 4 to both sides. Divide through by 3. Now, when you divide through by 3, just put the whole thing over 3. Now, you could put, if you wanted slope-intercept form, go for it. You could put 1/3 x plus 4/3. And then when you're done, you're not done until you've put it in inverse notation. So let's do that. So our final answer, just check your function. It was f. So we're going to write with that little f on it. If it was a g, you know, we'd go whatever it happens to be. And then, so our inverse is 1/3 x plus 4/3. Now, they want us to state the domain and range. So we found the inverse. We're going to talk about domain and range. We're going to graph it. We're going to do all the algebra and all that good stuff. Okay. So first, let's graph it. So I'm going to just make my graph paper ready, maybe. They're never this quiet. I'm just letting you. Have you come in once a week, just like that? Hey. Oh, I'll get you. I'm getting there. I know I can teach people stuff. I don't make me do your stuff, but okay. So now, what we're going to do, this is what's really cool about when you draw an inverse. Draw the line y equals x. Always have it on your graph paper. And I'm sorry mine's so bad, but luckily with technology we can fix it. That's pretty close. Okay. So there's the line y equals x, right? It goes through the origin. It has a slope of 1, up 1 over 1, up 1 over 1. Yeah. Okay. That line, what's really cool is the one graph should look as if we have rotated across that line and got the graph on the other side. An inverse switches the y's and x. So it should switch over the line y equals x. So that's just the line y equals x. Okay. Let's graph our first line. We're going to start at -4. Going to go up 3 over 1, up 3 over 1. I like to hit that y equals x line. It is a helpful thing to hit. Cross it over. Wait, that point's not in the right spot. Up 3 over 1, you know, all that good stuff. And then graph your line. You'd think as many lines as I've drawn in my life that I could draw something a little bit straighter, but okay. So that's our first line, that's F. Now, F inverse should appear as if I've rotated and smacked down a picture on the other side, okay? So I know my y-intercept, let's see. The y-intercept sucks. Let's see if the x-intercept is any better. So the x-intercept probably isn't much better, but it might be. Yeah, isn't it -4? Yeah. Now what's interesting is if our y-intercept for the one graph is -4, the x-intercept for the other graph will be -4. So that makes sense. My slope is 1/3, so just go up 1 over 3. Think about our other line. Our slope was 3. We went down 3 or up 3 over 1. Now we're only going up 1 and over 3. So it just reverses the process. You should hit the other line at your point of rotation around the line y equals x. So do you see how the one line appears as if, like if we had a way to rotate it. Sorry, I can't seem to. If we had some way to rotate it about, that's as close as I'm going to get. If we rotated it about this line, so think about if this was stuck and these two had like a nail or something stuck right there, couldn't we just go whoop and we could flip it and it would land exactly where it started every time? And that's the way you can check from the graph. An inverse will always rotate around the line y equals x because you have flipped the y equals x. The y's and the x's, okay? Any questions about where we're at so far? Okay, so now the last part we have to do, look at this part right here. It says to verify that the inverse of f of x is x. So what's interesting about inverses is f of x is the y. So if I inverse the f of x, the y should become an x again. That's what this is saying. So this is the way to verify you're right using a graphical sort of representation. Now let's do a way to find that the algebra is going to work, okay? So we're going to do that right there. So let me write this down. Now, it better equal x or you're wrong. That's just the way it goes. If we put the f of x into the inverse, you better get x. So what I'm going to do, we've done functions a million times last year. We've done them this year. So let's just do that notation. F of x is 3x minus 4. Let's put it there. Let's put it in so then we know what we're substituting in. Now, remember, our inverse, let me write my inverse over here. You can see it. So we found the inverse was 1/3 x plus 4/3. Let me write that better. Okay, so remember our stuff about functions. This is our input. We're going to put it right here. When we simplify the algebra, we're doing order of operations and all that other algebra stuff. Our answer should be x. We know what the answer is ahead of time, okay, if we did everything right. So we're going to do 1/3 of our input plus 4/3. Remember, our answer should be x. So we're going to input 3x minus 4. Now, when we input 3x minus 4, distribute in the 1/3 to both pieces. And that is 4/3. You can't read that? That looks horrible, doesn't it? It does. Okay, let's change that. How about 4/3? There you go. That's a little better. Okay, so distribute the 1/3. 1/3 times 3 is what? What is 1/3 times 3? 1, right? It's going to cancel out the 3. That's great. So that's just x. 1/3 times -4 is -4/3. What happens to the 4/3 and the -4/3? Is our answer x? They're inverses. We did it right. So there are two ways to verify that your answer is correct. You can graph it. It should do that flippy across the y equals x line. You can find the algebra of it. If you input the inverse into the original or the original into the inverse, you always get an answer of x, or you didn't find the right inverse, okay? Any questions there? We good? We're ready to go on? Oh, you're so cute. I didn't do domain and range. Linear functions. The domain of f is all real numbers. Please put -infinity to +infinity or the all real number set. I don't care. You pick one, unless it like actually asks for a particular one. The range of f is all real numbers. That one goes forever and ever, left to right, forever and ever, -infinity to +infinity. So this domain and range is nice. So the inverse is, this is the inverses range. So this one would be the range of the inverse. This one would be the domain of the inverse. So you should switch them around. The domain of one should be the range of the other and vice versa. This one, we don't have to think much. Both of them are all real numbers. So here's the ones that get screwed up. Square roots, fractions. You know how a fractional one, like 1/x, the the domain doesn't have 0 in it because you can't have that 0 denominator. Square roots, we know, have some restrictions. Same things. Some functions have restrictions, some do not. And we'll get to them when we get to them. Okay, did we do everything now on that list? I think we did. Okay. Now, let's look at this. It says for the graph of f, we see this square root of x plus 2. It says sketch the inverse by sketching the line y equals x and using symmetry. And then we're going to talk about domain and range. Okay, before we do anything else to this graph, this is what I want us to do. Let's write down the domain and the range of our original function. Now, domain we know about. We've talked about domain since last year. Domain we know about. Domain is determined by if the function's a fraction, watch out for that denominator. If our function's a square root, the inside has to be greater than or equal to 0. All those things we talked about before, okay? But now, let's talk about range. Range we avoided a little bit last year, unless we had the graphs. If we had the graphs, that was a different deal. But let's do the domain and range first. Okay, so the domain goes from -2 to infinity. Include the negative on a bracket. When you guys had a quiz recently, some of you forgot that bracket for a square root. So make sure you include that endpoint. This endpoint is a point that is allowed because you just get the square root of 0, which is perfectly fine. Okay, let's talk about range. Low point to high point. What's the lowest point of this graph? The lowest y value of this graph? 0. Can we stand there? So we include it in a bracket. How high can this graph go? Yeah, it can go as high as it wants to go. So it's going to infinity. Okay. Without ever drawing the new function, we already have the answer to domain and range for the new function. The domain of the inverse will be the range of the other. So the new graph will go from 0 to infinity. The range of our new graph will be the domain of the other, okay? So that's going to be -2 to infinity. Without even looking, I know that, okay? Because they flip-flop. So look, the domain became the range became the domain. If it didn't, something's wrong, okay? So I will sometimes answer that ahead of time so that when I go to draw my picture, I know where my thing should be located. Okay, now let's find the inverse. Inverse by the graph, and then we'll do the algebra too. They didn't ask for the algebra, but I want to show you the algebra. Now they said to draw the line y equals x. So I am going to try to put those points on there and draw my line. Now remember, it should flip across that line if I did it right. Okay, so I've got my line. That's the line y equals x. It's our guide when graphing. Now, for a graph like this, let's do a little trick. This is going to help. Well, hopefully it'll help you. Okay, let's write down that point right here. I'm just going to write it over on the side. That is the point -2, 0. So my inverse function has what point on it? What point? 0, -2. Okay, let's keep going. So I usually find 3 or 4 points, you know, the more the merrier, but okay. This is usually a good point, the next one over. That's the point -1, 1 on our original. So what's our point is on our inverse? 1, -1. Now you can do even decimal values, so you can guesstimate if you really want to get that shape of that graph. Another one good one right here is 2, 2. If it hits the y equals x line, what happens when we turn it? Anything special? No, it's still 2, 2, right? Okay, so now we have some good points. We got some points. Let's go ahead and draw those points, and then we'll kind of fill things in. Well, you know what? Let's get a point over here. Let's see. So let's go. So 1, 2, 3, 4. Well, we're going to have to guesstimate, but well, I think we'll be okay. Let's try it first. Okay. What kind of graph paper do you guys have? Let me see. Oh, it's the same thing? Okay. I didn't know if you had anything special. Okay, so guys, we're going to need to extend this down here. So do your best to kind of get that. Okay, so our first point is 0, -2. Put it on there. Our next point was 1, -1. Put that on there. Our next point was 2, 2. Now, all that's giving us is this portion. So look, see how it should look symmetric? It should be symmetric across the line y equals x. See, I mean, as best as I can do. Now, the only thing we don't have is this tail here. See this little tail? So let's make it keep going. And you just got to guesstimate. If you would like, if we had official graph paper, I might actually put another point on, but I don't have anything official. Okay. So we've drawn it. We've sketched a graph. We have identified the domain and range. Okay, the only other thing I want to do is the following. I just want to show you the algebra a little bit. Okay, so our original graph was y equals the square root of x plus 1, or x plus 2. Let's turn the x and y. We got to solve for the new y. Get it by itself. Can somebody tell me what's the step I should take? Where should I go next? How can I get to that y there? Square both sides. How can I now get the y by itself? Subtract 2. Our inverse function is x squared minus 2. Now, if my drawing was a little better, here, I think it's my tail is kind of gross here. Do you see how technically it's a parabola? But haven't we restricted? Do we use the whole parabola? No, look what this says. We're only using the parabola from 0 to infinity. So we're only using the parabola on that side of it, that positive version of it. Okay? Any questions about that one before I move on? They seem so excited, don't they? Okay. How many thousands more do we have? Oh, we're getting there. It'll only take us a few days. Okay. Let's take a look at this one. Well, today and tomorrow, I think we'll take these notes because we have to do the trig functions. We'll stop and do the trig functions probably tomorrow so you can start your homework. Okay. So it says consider the function f of x equals x plus 1 squared. So it's that parabola again. Okay. You're welcome. No problem. Okay, it says sketch the graph and use the horizontal line test to show that it is not one-to-one. We already know our parabolas are not one-to-one. And show that if we restrict the domain from 1 to infinity, we will be able to call it a one-to-one function. Okay, so let's think about the graph of this. You guys are all quiet. Okay, so f of x equals x plus 1 squared. How has our new parabola been transformed from our old? Say that again. It's been moved to the left one. So let's draw our parabola, guys. Yeah, that's right, too, isn't it? Wait. I said left, didn't move left. Carly said left, I didn't move left. Sorry about that. Thank you. Okay. So that is our new function. Now, what they said is show that it is not one-to-one. So right now, look, fails that horizontal line test. Okay. But if we restrict the domain, so if we only worry about x values from -1 to infinity. So if we remove this part of our graph, bless you, bless you some more. I'm going to kind of keep a little version there, but if we only look at the graph from -1 to infinity, now it becomes what we want. Now, we'll talk about finding the inverse in a second, but what I want to do is let's talk about the domain and range of this and what the domain and range will be of our inverse. Okay, so the domain of f, we have to restrict from -1 to infinity. You can choose the negative side. It's not as common, okay? The range of f is 0 to infinity. So if we were to find an inverse, the domain of that inverse is the range, 0 to infinity. The range of that inverse is the domain, -1 to infinity, without even drawing the picture, okay? We're going to draw the picture. We're also going to find the inverse. So let's make it y equals x plus 1 squared, which becomes x equals y plus 1 squared. Now, what's going to get rid of the square root? Or the square? A square root. Okay. What do you have to put in front of a square root when you are the one that inflicts it in the problem? A plus or minus. Did we use the plus? Did we use the minus? If we use this side of our parabola, you pick the minus. If you choose the positive portion of your parabola, you choose the plus. So now let's rewrite it so we just have the positive. And then we're going to move that 1 to the other side. So we get the square root of x minus 1. So that's our inverse. So isn't that just our square root function scooched down one, right? So that looks like this. Would you agree if we folded across that line, it's a perfect match? Okay. So, inverses, that's what it is. Now, we are going to talk more about trig functions. Let's just do this one last slide, and then tomorrow we'll talk about trig functions, okay? Any questions before everybody got that before I move on? Okay, let's look at this one. It says an f and g are inverses, then f of g equals x and g of f equals x. I couldn't type it out very nicely at the time when I made this. That's that notation. Let me write it a little nicer. So that fog, that goff, that composition will always get you x. So if they say determine if the following are inverses, all we have to do is compose them and get x every time. If you get x both ways, you found the inverse. Okay. So this one, we're going to do f of g of x. This one, we're going to do g of f of x. And our answer both times should be x, or we don't have correct inverses. Okay. So this one here, we're going to take out the x, and we're going to replace it with x minus 3 over 8. Now, when we do that, what's going to happen to the 8's? Cancel out. So cancel those out. And we get x minus 3 plus 3, or x. Bam, first way is right. Because we should always get x, because technically what happened is you stuck in a y, and in the inverse, it becomes an x. We're not done determining if it's right unless it works both ways. So now we're going to do it in the other one. So this time, we're going to take into the g function where the x is sitting right here, we're going to put in f of x, 8x plus 3. So we're going to get 8x plus 3 minus 3 over 8. Well, what's going to happen to the plus 3 and the minus 3 on top? It's going to cancel, right? And so you're going to get 8x over 8, which is x. Bam, it worked. So yes, those ones are inverses. Now, if one way doesn't work, you immediately go, we're good to go. Yes. So we're going to take out the x. See, our input has become f of x. So I took out the x and I replaced it with f of x, which was 8x plus 3. So that's your f of x. Okay, now the next ones, what's going to get rid of a square? A square root. What's going to get rid of a cube? A cube root. Can you look at these? Are they going to be inverses? No, but let's just show you one way and then I'll prove it to you, okay? Hopefully. So here, if we take the f function and we plug in the g function, 1 over x plus 1, we get 1 over x plus 1 cubed plus 1. Is that going to reduce down to x? No, absolutely not. It's going to be disgusting. So that's a no. Okay? If it worked one way, you still should check the second way because it might undo itself in a funky way. Okay? So now, we're going to talk about the trig functions tomorrow. But if you look at down below, don't look at the solutions. But if you look down below, try all the ones that aren't trig functions. So you're ready to do everything but that bottom section. Okay? Okay. So there you go.